Good morning, students. I hope you all are well and doing mathematics comfortably. We people are doing volume of revolution, and today is the fourth example on this particular topic. We have done when the equation of the curve is given in Cartesian form as well as in polar form, but when it is rotated about x-axis or y-axis. Now this is the question in which you find the rotation is neither about x-axis nor about y-axis. This type of question we have done in surface of revolution. So let us see. Find the volume, आयतन ज्ञात करना है, of the solid ठोस का जो इस कर्व को उसके अनंत स्पर्शी के सापेक्ष घुमाने से बनता है। एसिम्पटोट अनंत स्पर्शी। So let us consider curve is y square times 2a minus x equals to x cubed implies y square equals to x cubed upon 2a minus x. Now remember, y has an even power. So curve is symmetrical about x-axis. सममित। कर्व ट्रेसिंग आपको आना चाहिए बहुत अच्छी तरह से। कर्व इज सिमेट्रिकल अबाउट एक्स एक्सिस, जैसा एक्स एक्सिस के ऊपर है वैसे एक्स एक्सिस के नीचे बनेगा। ये इसका पहला पॉइंट है। सेकंड, x tends to 2a, the denominator x tends to 2a, y tends to infinity, therefore x tends to 2a, y tends to infinity, therefore x equals to 2a is the asymptote of the curve. जैसे जैसे x 2a के नजदीक जाएगा y जो है वो किसको टेंड करेगा? इन्फिनिटी को। सो x equals to 2a is the asymptote of this curve. And remember, x equals to 2a is parallel to y-axis. Now we trace the curve. X equals to 0, when x is 0, y is also 0, so it passes through the origin. Third point I write, y square equals x cubed upon 2 minus x, therefore y equals to plus minus x cubed upon 2a minus x. So the whole curve is lying between 0 and 2a. This is the line. This is x equals 2a. यदि यहाँ पर x 2a होगा तो पूरा डिनोमिनेटर 0 हो जाएगा और y इंफिनिटी हो जाएगा, तो ये लाइन को केवल इंफिनिटी पे जाके टच करेगी, इसलिए कर्व है वो इस तरह से बनेगा। ऐसे अनंत स्पर्श एसिम्प्टोट। जैसा एक्स एक्सिस के ऊपर वैसे एक्स एक्सिस के नीचे है। जनरेटेड बाय द रिवोल्यूशन अबाउट इट्स एसिम्प्टोट। न तो एक्स एक्सिस के रेस्पेक्ट में रोटेट करवाना है, न वाई एक्सिस के रेस्पेक्ट में रोटेट करवाना है, इसको रोटेट करवाना है एसिम्प्टोट के अबाउट। इसके अबाउट रोटेट होगा, मीन्स इट इज like this is the rotation, rotated about asymptote। कॉन्सेप्ट क्या है? टूल याद रखो, जस्ट रिमेंबर about x-axis. Suppose when we drop the strip, this area is rotated, okay? ये जो रेक्टेंगुलर स्ट्रिप है, जो पट्टी है, हम उसको रोटेट करवाते हैं। Suppose this is the point P, here it is M, this is Y. Coordinates of P, that is x, y. यहाँ से परपेंडिकुलर ड्रॉप किया। So this is phi। जो पट्टी बनी, जो डिस्क बनी है, वो सर्कुलर होगी और उसके बेस का जो एरिया होता है दैट इज पाई आर स्क्वायर। सो पाई जो है या रेडियस दैट इज पाई वाई स्क्वायर, और एक्स एक्सिस के रेस्पेक्ट में है इसलिए dx, और x के लिमिट जो है वो यहाँ से यहाँ तक। दिस इज द बेसिक वन। नाउ इट इज रोटेटेड अबाउट दिस लाइन, इट इज रोटेटेड अबाउट दिस लाइन, सो वी हैव टू ड्रॉप द परपेंडिकुलर। हमें लंब डालना है, ये कर्व है, इस कर्व को यहां से पॉइंट और ये परपेंडिकुलर, ये स्ट्रिप लूंगा मैं, ये वाली पट्टी, और ये जो एरिया है ध्यान रखना, इस कंप्लीट एरिया, ये वाला पार्ट, ये इस लाइन के अराउंड घूमेगा ऐसे। तो ये वाला पार्ट और ये वाला पार्ट, अब देखो जैसा इसके ऊपर है वैसा का वैसे, तो ये डबल बनेगा बिल्कुल। सो हियर आई राइट P, कोऑर्डिनेट्स ऑफ P दैट इज x, y, और उससे कंपेयर करते जाओ। ये P है बना, यहां से यहां तक, ये पॉइंट है 2 है, यहां पर ये यहां से सपोज दिस इज n, तो ये इसका x कोऑर्डिनेट हुआ, दिस टू दिस, एंड so PM is suppose this point is Q for example, then PM is equals to NQ. PM is equals to NQ, and what is NQ? That is OQ minus ON, OQ minus ON, and this is 2A minus X. तो PM जो है वो 2A minus X है। यहां जो इसका रेडियस है वो y है, जो डिस्क है। यहां रेडियस जो है, क्योंकि वो इस तरह से मूव होगा, सो इट इज 2a minus x, एंड दिस इज पैरेलल टू y axis, so instead of dx we will write dy, okay? So just remember this. Again the limit, here it is y equals to 0, y equals to 0. This approaches to infinity, so y equals to 0 to y tends to infinity. ये ध्यान रखना है, लिमिट जो है 0 to infinity, और ये इस तरह से रोटेट होगा। दिस इज सिमेट्रिकल अबाउट दिस लाइन, सो कैन से दिस। व्हाट इज द रिक्वायर्ड वॉल्यूम? Therefore, the required volume equals to pi y square, एरिया ऑफ बेस। सर्कल का जो एरिया है मैंने कंसेप्ट में बता रखा है, पाई आर स्क्वायर। यहाँ जो रेडियस बनेगी वो पी एम, दैट इज पाई Pn whole square, and it is parallel to y because this line is parallel to y axis. Okay, so dy limits 0 to infinity. इन्फिनिटी पे जाके इसको ये टच करेगा, इसलिए एसिम्पटोट है और हमें ये पूछा है इसको एसिम्पटोट के रेस्पेक्ट में रोटेट किया है. दिस इज 0 to infinity by Pn. Pn is 2a minus x whole square dy. यहाँ एक इंपॉर्टेंट बात है, क्योंकि इंटीग्रेशन y के रेस्पेक्ट में है, you can see. तो ये पूरा का पूरा पार्ट जो है वो y के फॉर्म में आना चाहिए. अब मुझे यहां से y के फॉर्म में कैलकुलेट करना मीन्स मुझे x को कैलकुलेट करना होगा. यहां से मुझे x एलिमिनेट करना पड़ेगा, एंड इट इज डिफिकल्ट टू एलिमिनेट x. सो व्हाट टू डू? दिस इज 0 to infinity. This is pi. This I write 2a minus x whole square. This I write dy by dx, and here is dx. Notes. क्या कर दिया मैंने? इंटीग्रेशन का जो वेरिएबल है वो चेंज कर दिया है. यहाँ मैंने लिखा dy by dx. यहाँ से मैं dy by dx कैलकुलेट करूंगा. जब मैं dy by dx कैलकुलेट करूंगा तो यहाँ से 2a minus x यहाँ से रिपीट हो जाएगा, और पूरा का पूरा जो टर्म है वो केवल x में आ जाएगा. तो अब यहाँ पर लिमिट जो है वो किसके रेस्पेक्ट में आएगी? वो x के रेस्पेक्ट में आएगी. x की लिमिट जो है वो कहाँ से कहाँ तक जाएगी? वो 0 से 2a तक. एक और बात, क्योंकि डबल हो रहा था इसलिए इट इज 2 टाइम्स, और x की लिमिट ध्यान रखना है ये x के रेस्पेक्ट में है. x की लिमिट 0 to, here it is x equals to 0, and this is x equals to 2, so it is 0 to, इसको यहाँ से हटा देता हूँ मैं और ये आपका 2 है. Okay, so this is equation number 1. So this you have to remember. Again I repeat, it is rotated about this line. This is parallel to y-axis. So this is the basic part of it. When we simplify this, it must be in terms of y because here the variable is y, but it is difficult, so we use dy by dx, and dx, so the limit will be with respect to x, and x is from 0 to 2a. So you remember this. Now we find dy by dx. Okay. Just calculate it. Now y square equals x cubed upon 2a minus x on differentiating with respect to x. 2y dy by dx equals to 2a minus x whole square, denominator square into denominator, differentiation of numerator, that is 3x square minus x cubed times differentiation of this, that is minus 1. Okay. It is 2 3 is 6 x square ax square minus 3x cubed, then it is plus x cubed upon 2a minus x whole square. Okay, so this is 6 is x square, remember 6ax square minus 3x cubed, so it is minus 2x cubed. 2a minus x whole square equals 2x square is common, that is 3a minus x. 2x square is common. So yes, it is 6x square minus 2x square upon 2a minus x whole square. This is dy by dx, okay? 2y, so this 2 and this 2 is cancelled out, so therefore dy by dx equals to x square into 3a minus x upon 2a minus x whole square into y. 2 and this 2 is cancelled out, okay? So it is this one. Now the value of y, so this is x square 3a minus x upon 2a minus x whole square into the value of y, means square root of this, so it is x root x upon root 2a minus x. Okay, now we'll simplify this. So this is x to the power 3 by 2 and here it is x square. So root x is left. It is root x. It is 3a minus x. Then it is power is half, so it is 2a minus x to the power 3 by 2. 2 power and half power, so 3 by 2 power is left. Therefore, from first required volume equals to two pi 0 to 2a, 2 pi 0 to 2a, 2a minus x whole square into, okay, I write as it is. It is x square 3a minus x upon okay, I write this one. I am writing this x square 3a minus x. So it is 2a minus x whole square into x root x upon root 2a minus x dx. So I just cancel out this out. Okay. So this is 2 pi 0 to 2a. This is root x 3a minus x root 2a minus x dx is left. I think this goes to up and here it is x to the power 3 by 2, so root x. This is the final part of this. Now we make the substitution. So let x equals to, here it is, 2a sin square theta. Therefore, this is 2a into 2 sin theta cos theta d theta. We use the limits. X equals to 0. X is 0, then theta is 0. Changing the limits is very important. So here is the substitution. X is 2a. Then 2 and 2 is cancelled out, it is 1. Sine is 1 when theta is pi by 2. So it is theta is pi by 2. So this is 2 pi, limit 0 to pi by 2. Root x means root of this, it is root 2a into sine theta. Remember this. It is 3a minus x means it is 2a sine square theta. Okay. Then root 2a minus 2a sine square theta into dx. Dx is 2 into 2, 4 a sine theta cos theta d theta. It is this. Little bit time consuming, but it needs a practice. Several times I told you, you must have strong practice on integration. Otherwise it is difficult. Pi. Let us handle the constant. This is root 2a. Here it is root 2a. Then a is common, so I write it here a also. Then again it is root 2a. Then it is 4a. These are the constants. 0 to pi by 2. Now the left part. Here it is sine theta multiplied by 3 minus 2 sine square theta, because a is common here. Then it is 1 minus sine square theta, that is cos theta. 2a, that is root 2a is out. Okay. Then 4 is as it is. Then it is sine theta cos theta. Sine theta cos theta d theta. Now this is 2 to the 4 to the 16. Root 2 into root 2 is 2, 4 to the 8 to the 16, then here it is pi. This is a, and here it is also an a, so it is 16 pi a cubed. 2 root 2 into root 2 is 2, 4 4 to 16, pi it is, here it is a and a, so it is a cubed, and it is 0 to pi by 2. Let us multiply that. 3 minus 2 sine square theta into sine square theta cos square theta, this into this, and here it is d theta. Okay. This is 16 pi a cubed. It is 0 to pi by 2, 3 sine square theta cos square theta d theta minus, this is 2 times 0 to pi by 2 sine to the power 4 cos square theta d theta. Yes. Now here the integration, this you can handle easily, but it is little bit tricky. So there is one more concept. This time I use gamma function, that is the next chapter. Gamma function, it is 0 to pi by 2 sine to the power n cos to the power n dx. This is gamma n plus 1 by 2 gamma n plus 1 by 2 upon 2 gamma n plus 2 by gamma in physics, you know that it is just like this is capital A, this is small a. So here it is, this is capital gamma and this is a small gamma. In physics you have noted this symbol gamma. So gamma half, practically we will prove this is root pi. And how to operate this one? Suppose I write gamma 5 by 2 for example. Then this is 5 by 2, so one less of odd numbers, it is 3 by 2, 1 by 2 into root 5. This is the trick to open this one. We will discuss about later on. And if it is gamma 4, for example, the natural number, then it is factorial 3, 1 less this one. So you have to remember these digits. Okay, so this is to be noted. This is 16 pi a cubed 3 times. Write the answer. M is 2 and n is also 2. So m and n both are equal. So here it is gamma m is 2. Remember, so it is 2 plus 1 by 2 gamma again 2 plus 1 by 2 upon 2 gamma n plus n, that is 2 plus 2 plus 2 upon 2 minus 2 times gamma m is 4, so it is 4 plus 1 by 2 gamma 2 plus 1 by 2 upon 2 gamma 4 plus 2 plus 2 upon 2. It is this. Okay, let us simplify this. This is 16 pi a cubed multiplied by 3. This is gamma 3 by 2. Gamma 3 by 2 upon 2 gamma 2 plus 2 plus 2, that is 6 by 2, so it is gamma 3 minus 2 times gamma 5 by 2 gamma 3 by 2 upon 2 gamma 4 to 6 to 8, so it is gamma 4. 16 pi a cubed 3 gamma 3 by 2 5 by 2, then next reducing odd number is 3, so it is 3, so it is 1 by 2 into root pi. Similarly 1 by 2 into root pi. This is 2 gamma 3 is a natural number, so one less factorial. Gamma 4, then factorial 3, so it is gamma 3 and it is factorial 2 minus 2 times gamma 5 by 2, so it is 3 by 2 1 by 2 root pi into 3 by 2, so it is 1 by 2 into root pi upon 2 factorial 3 gamma 4, that is factorial 3. Now we simplify this. 16 pi a cubed, okay, so it is 3 pi upon 2 to the 4 to the 8 to the 16, so it is 3 pi upon 16 minus this 2 and this 2 is cancelled out. You remember this factorial 3 means what? Factorial 3 means 3 into 2 into 1, so it is 6 and this 3 is cancelled out, so 2 is left, so it is 2 into 2 into 2 into 2, so it is 16, so it is pi upon 16. Okay, this is 16 pi a cubed. 3 pi minus pi is 2 pi upon 16. This 16 is cancelled out, so it is 2 pi square a cubed. So this is the yes volume of that particular solid. So you don't worry about this gamma function. We will consider this particular chapter because it is in your syllabus, but you remember this formula. Once you have understood that, you can solve this one easily. So this was the last part of this particular topic, and you remember 100% one question is asked on this particular article, that is volume and surface area of solid of revolution when the curve is rotated about either x-axis or y-axis or about any line. So I hope you have understood. If you have difficulties, comment in comment box. Thank you very much. Jai Hind.